All right, we are going to take a look at how to do a hypothesis test for two proportions. So this would be if we want to compare the proportions for two different groups. So we have our sampling distribution. So P1 hat would be the sample proportion for the first group. P2 hat is the sample proportion for the second group. P hat is the overall sample proportion. The sample standard deviation, that's this guy. Ooh, where did it go? There we go. Is the following formula. And then we have our z-score, which in the hypothesis test is going to give us our test statistic. Now, I am not going to show you how to calculate any of this by hand. I am not going to expect you to do any of this by hand. We are going to let Excel do all of these calculations for us. We are not going to do any of this by hand, not even the example. So we are going to jump into that example. So in clinical trials of Nasonex, 3,684 adult and adolescent allergy patients were randomly divided into two groups. The patients in group 1, the experimental group, received 200 milligrams of Nasonex, while the patients in group 2, the control group, received a placebo. Of the 2013 patients in the experimental group, 547 reported headaches as a side effect. Of the 1,671 patients in the control group, 368 reported headaches as a side effect. Is there significant evidence to conclude that the proportion of Nasonex users who experience headaches as a side effect is greater than the proportion in the control group at the alpha equals 0.05 level of significance? So there's a lot of information to unpack in here. So the first thing is we were looking at 3,684 adult and adolescent allergy patients. We divided them into two groups. So that's going to tell me, okay, I'm looking at the difference between two proportions compared to comparing a single proportion to a given statistic like we were doing before. We have some background information about what the two groups were. There were 2,013 patients in the experimental group, and 547 reported headaches. 1,671 were in the control group, and 368 reported headaches. Is there significant evidence? So significant evidence, that tells me that this is a hypothesis test, to conclude that the proportion of Nasonex users who experience headaches as a side effect is greater than the proportion in the control group. So is Nasonex greater than the control group? And then we have our level of significance. So again, lots of things to unpack in there, mostly the numbers. So I'm going to go ahead and I'm going to take all of those numbers, 3684, 2013, 547, 1671, 368, and 0.05. So 3684 is the total number of people that were in the study. So that would be my sample size, my total sample size N. 2013 were the number of patients in my experimental group, which was group 1. So I'm going to call that N1. It's the number of people in group 1. 547 is the number of people with headaches with the trait that I'm looking at. So that's going to be X1. My control group contains 1,671. So that's the number of people in group 2. And 368 is the number from that group getting the trait that I'm interested in. So that's going to be X2. So what we need to identify when we're looking at these problems are how many people are in each group, N1 and N2, and then how many people from each of those groups have the trait that we're looking for. And in this case, we're looking for headaches. So I have the number of people in each group and the number of people from those groups that got a headache as a side effect of the medication. Now the people in group 2, in that control group, they don't know that they received a placebo. They think they're receiving this allergy medication. So their brain is potentially tricking them into thinking that they're getting these headaches as that side effect. So we want to know, is that significant? Are there enough people actually getting headaches who are on Nasonex for us to say that Nasonex is causing them to get headaches? And then level of significance, that's always our alpha. Same thing there. So the first thing I'm going to do is I'm going to write my null and alternative. Now this is going to look pretty similar to what we were doing before, with one slight alteration. We're still going to start with HO and HA. But now in our null hypothesis, we are going to assume that the proportion in group 1 is equal to the proportion in group 2. So the percent of people getting headaches between the two groups is equal. I don't know if it's equal to 5%, 20%, 75%. I don't really care what it's equal to. What I want to assume is that they are the same. It doesn't matter whether the people were getting Nasonex or the placebo. The percentage of people getting headaches is equal between the two pills. And then we want to know, is the proportion of people on Nasonex getting headaches greater than the proportion from the control group? So Nasonex was the experimental group, that was group 1. So is the proportion for group 1 greater than the proportion for group 2? So it's very important as you're going through this, and it can be helpful as well, to go ahead and identify for yourself, okay, this is my Nasonex group. Those are my 1s. And my 2s are my placebo group. So then when you come down here, you know, okay, P1, this represents the population proportion. If I were to put this out for everyone that would be getting headaches on Nasonex, and P2 would be the placebo. If this problem had asked for us to see if the proportion on Nasonex is less than the control group, then we would simply change this middle symbol to a less than. If it had asked if the two groups were different, then we would have the not equal to. Otherwise, it stays the same. So only that middle symbol is going to change between the null and the alternative. Just like the only thing that should change between your null and your alternative when you're looking at one proportion compared to a given statistic, a given value that you're comparing it to, the only thing that's different between the null and the alternative is this symbol. So I have my null and my alternative. So I'm going to use Excel to find my test statistic and my p-value. So that's step 2 and 3 of our hypothesis testing steps. And then we're also going to do Excel to get our p-value. So let me go ahead and pull up Excel. I already have all of the data plugged in. So on our Excel file, scrolling down at the bottom, we had our table of contents. And then if we keep scrolling, we'll see 2 sample test proportions. So this is a 2 sample test because I've taken a sample of people on Nasonex and a sample of people getting the control medication. So I have 2 samples of people. Let me zoom this out just a little bit. So notice here, you cannot change a whole lot in the null and alternative. The only thing you can change is the symbol. So we want to make sure that we put that on the greater than symbol because we want to know, is P1, the Nasonex group, bigger than P2? X1 was the number of people getting headaches on the Nasonex medication. That was 547. N1, the number of patients getting Nasonex in the experimental group. That was 2013. X2, the number of people on the placebo reporting headaches, 368. N2, the number of patients receiving the placebo, 1,671. And then we plug in our alpha. Again, that's for the other method of doing a hypothesis test that I have not shown you, but you are welcome to use if you have done your own research and looked at how that method is used. So we have a lot of values here. We have p hat 1, so about 27% of the people on Nasonex are reporting headaches. P hat 2, about 22% of people are reporting headaches from the control group. P hat is our overall percentage. So we've got just under 25% of our experiment as a whole are getting headaches. And then our standard deviation value. But what we want is that test statistic. So that's our Z with the 0 next to it. So 3.6021. And our p-value. Remember, the p in p-value stands for probability. So your answer should always start with a 0. And it's a probability, so probabilities always go to 4 decimals. So we have a test statistic of 3.6021 and a p-value of 0.0002. So then we can go ahead and come to the conclusion and write an interpretation. So the conclusion for a hypothesis test, we want to ask ourselves, is the p-value less than alpha? So is the probability of the results from our samples too unlikely to be possible? So our p-value is 0.0002. Is that less than 0.05? Yes. Our probability, our p-value is too small, so we reject. Our p is low. We are going to reject HO, reject the null. And that means that there is enough evidence. Remember, the evidence is the p-value. A low p-value means there is enough evidence. A high p-value means there is not enough evidence. So there is enough evidence to support the claim that the proportion of Nasonex users reporting headaches as side effects is higher than those on the, I'm running out of room, placebo. And that is what you will do for a hypothesis test when you are comparing two groups with proportions. So you don't have to do anything by hand. I have the formulas up here just so you can see, hey, these formulas in Excel are being calculated using these formulas at the top of my notes. That's the formula that's being used. But I am not expecting you to do any of this stuff by hand. I want to see, can you write the null and alternative? Can you take the p-value and come to the right conclusion? And can you interpret what that means? And that's it.